All right, this is another example of a question talking about radial loading and axial loading condition. All right, it's still asking you to use manufacturer catalog methods to find whatever um, bearings you need. So a pair of deep groove ball bearing, okay, here, a pair. There's two ball bearings required for a 40 diameter shaft. So the ball is 40 and you rotate at 750 RPM. The shaft carries a stationary radial load of 1000 Newton at its center span. That means equally divided, equal distance, and an axial load of 1500 Newton, okay, acting on it. So the rating life required is 6000 hours, okay, the requirement. The loads are equally shared by the bearings, okay. The question says that will make life easy for you. So determine the bearing number based on the condition given. So the loads are equally shared, stated here. So your FR is 500 Newton. Okay, 500 here, 500 here. Okay, let me 500. That's your FR. So your FA is 750 because 1500 divided by 2 share equally. So this will be my values for individual bearing. And we assume that the bearings are supposed to have the same spec because it's a pair. So to find a suitable bearing, we do trial and error method. Start from the smaller size. This is a good practice because you don't oversize it. It's like you don't you purchase a laptop based on your needs. Okay, you don't go to a computer shop and say that buy an Alienware, but I'm using it for Microsoft Words and Excel file, right? So you pay 3000 to 5000 Alienware specs, and you just use it for your PowerPoint or your Excel file usage, right? So or you don't buy the lowest range spec and go and play Counter Strike or whatever computer games where the graphic card cannot support. So you got. So our first try, based on the catalog, we go to the ball diameter of 40 The first bearing number is 6808. We will use this to try and trial whether we can use this bearing for the concept condition. So from 6808, I can obtain the COR will be 3650 Newton. This is from the catalog COR. So going to the chart here, where to find my PR with the radial and axial load condition. So the first column says that I need to have FA over COR. So I punch in the number 750 divided by 3650. Again, this 3650 is from the catalog of 6808, which we use the first try because this is the first bearing. Okay, first bearing. So 3650 and you get 0.205. So 0.205 fall in between 0.20 and 0.30. Right? So my E is 0.35 and 0.38 obviously is smaller than 1.5. Right? So it's smaller than 1.5, then my FA over FR 1.5 is greater than E. So this is the column I'm interested in. Having that, I know that my X is 0.56. All right. But what happened to my Y? So 0.02 and 0.03, sorry, 0.2 and 0.3. So I value is 0.205 point between here. So you can do an interpolation, you will get about 1.25 something. So we use 1.25. Okay, you punch in the 1.25 and you'll get 1217.5 Newton. So that is my PR. Okay, the formula is given here. So what you need to do, you find your X and Y. Y you need to interpolate. You have a FA and FR. So you substitute in, you get 1217.5 Newton. So using the nomograph, I have my FH and FN. So my FH is 6,000 hours. Okay, this is given a question. I use it on the left hand side, ball bearing, 6,000 hours, I get 2.3. My FN, rotational speed 750 RPM, I refer to a nomograph, I should read about 0.35. Okay, you should have these two values on hand, so I can find my calculated CR. So when I go to my calculated CR, I punch in the variables I have, my PR, FH over FN, I get 8,000 Newton. So this is my required CR in fact. That means based on all these conditions, I need a CR that is greater than 8,000. But if you refer to 6808 catalog, okay, the catalog CR is only 3,009, which is way below the required calculated CR. So this bearing is not suitable. Our first attempt for this question used 6808 bearing, and after comparing the calculated CR with the 6808 catalog CR, you realize that the catalog CR is smaller than the required calculated CR. So we are not able to use 6808, so we would use 6908 bearing, which is below 6808 in the catalog for second try. So using bearing 6908 with the COR will be 7450 Newton. This is from the catalog. Okay, so you go to 6908, you look at the COR, is 7450 Newton. So we will restart everything again. Yes, it's very painful. So FA over COR, my FA remains the same 750, but this time around the COR changed. COR is 7450 because 6908 bearing. And you divide it, you get 0.1. Very beautiful because 0.1 is exact reading. So my E is 0.29. My FA over FR ratio still remains the same because the condition remains 750 divided by 1.5. 1.5 is greater than 0.29, so I still having the extreme right column. X is 0.56. Now my Y easy, no need interpolate because it's 0.1. So direct reading, Y, a direct reading from 0.1 will be 1.48. Beautiful. No interpolation required. So I substitute in all the variables using this equation, and I'll get 1390 Newton. Right, so my PR is 1390 Newton. So 6,000 hours remains the same, 750 RPM remains the same, so my FH and FN is the same. So one time reading, still the same value. Substitute in, but the PR is changed, where my FH and FN remains. So my new CR for 6908 after calculation will be 9,134 Newton. So this is a calculated CR based on 6908 COR conditions. So we go to the catalog again, look at 6908, compare the catalog CR. The catalog CR given is 9350 Newton. Well done. 9350 Newton is greater than 9134 calculated CR. So therefore, this bearing 6908 is suitable and will be selected for this question. Let's say after the second attempt, 6908 CR is still smaller than the catalog CR is smaller than the calculated CR, and then you have to do your third try. The next available bearing below 6908 and subsequently keep trying. So this is what we call sizing. But of course, experience after numerous of work on this area, you should be experienced enough to narrow down to based on the condition given and narrow down to the few bearings that you can straight jump to. Of course, this is your first session, so we would recommend you to start from the beginning and work it way down. Okay, we have concluded the bearing calculation and selection of methods using equation and nomograph. So you can try it out the the last two example using equation to solve the problem. Other than that, if not, then we will go into summary.